Right, so let's take a look at how we would model inheritance. We had discussed this a little earlier, that it was challenging to model inheritance in relational databases since it's it's a foreign concept in relational databases, right? So databases predate object-oriented technology, right? Before it became so pervasive and ubiquitous. So there is no concept in how to capture inheritance. But in object orientation, it's such a common concept. And here we have user as a base class and faculty and student inheriting from the user. So from the point of view of the object world, inheritance is very simple. You have a base class, in this case user, and you have a faculty that extends from user. And now, if you remember, user had a description of a primary key. It had ID and declared it as an ID, and it was a generated value and whatnot. But here, faculty, because it's inheriting from user, it would be redundant to also declare here an ID, especially depending on some of the strategies by which we can implement this. So, for instance, if we create a user and then we inherit. Faculty inherits from user, the default implementation is to use what it's called the single table inheritance strategy, right? Also sometimes referred to as the denormalized strategy. Right? Notice that what has happened here is that the original user table, right, that declared the primary key, declared the four class variables, first, last, password, and username, now it has been enhanced to add additional fields that were not there originally. Right? It added 2 fields to be able to capture the fields from this new faculty class, right? Plus an additional field called dtype. Right? This dtype is referred to as the discriminator field. Right? It's not like it's discriminating faculty versus users or anything like that. It's just to be able to distinguish between the two. Yes. No, in the single table is only one. It's it captures all the fields from both the user table, the user class and the faculty class into one single table, right? Usually you would avoid doing this from a data model perspective, right? That if you have 2 concepts, you would have them implemented as separate tables, right? Now, the default implementation is actually the most common implementation, right? What you do is that when you insert a user, then all the fields, first name, last name, password, and username would be populated, and the value of dtype would be the name of the class that was used to instantiate that class, right? That object. So if you instantiate it using user and you save it as a user, then dtype would be user. If instead you instantiate a faculty and you also provide the same thing, first name, last name, whatnot, but you additionally provide the office and tenure, the record will have both. Will have values for the first and last name plus the office and tenure. And the value of dtype will be faculty. Okay. The dtype is needed by JPA to be able to distinguish what should I instantiate, right? If I search for a faculty of a particular ID, it needs to know, right, that indeed it found all the faculty, right? And for instance, if you do a query that says, well, give me all the users or give me all the faculty, right? It can distinguish. It says, well, I'll give you the users or I'll give you the faculty, right? And it distinguishes using this dtype varchar. Okay. Obviously, one of the things that we don't like from this approach is that if you instantiate a user will not have an office, will not have a tenure, and those values would be null, right? And usually, as coming from a relational database, we cringe at that, because of having very sparse tables, right? Especially if you have, lots of chains. If your inheritance chain here is very deep, we have user, faculty, and your tenure faculty, and blah, blah, blah faculty, a whole bunch of types of faculty, or staff and whatnot, and they're all inheriting from each other. then you end up with very sparse tables. With a very sparse user table where some of the fields are filled, but most of them are null, right? And that drives DBAs crazy. But from the implementation, it's very easy. And obviously you would not do queries yourself. You would not use this table yourself. Instead, you would always go through an API, right? The JPA API would be handling this for you instead of you manually handling this for you, right? Um, Here's another one. The student also extends user, and it has a graduation year and has scholarship. Notice that now the user table has grown even bigger, right? By adding these additional fields, graduation year and has scholarship. Again, those two fields would be null, right? If this were just a faculty or if this is a plain user, those two fields would be null. Right? So that's the obviously you could also implement repositories for each one individually, right? So you could create a repository for students, repository for faculty, so that you can say find all faculty. So if you have 1,000 users, maybe a couple hundred of them are faculty. So it would return all the instances where the D type is faculty. It would return all the faculty. Same thing for student, right? It would return all the students where this D type would be student. So here we just have some examples of inserting